Our point of departure is that most policymaking involves sequential choices. Politicians in office make typically more than one choice between moments of accountability. And although there is a significant literature on multitask, there isn't so much on the consequences of the sequential nature of the choices. And this is what this paper and some of the other papers that we've done is supposed to be about. One of the other things I want to mention, by way of motivating it, is that there's a robust evidence of intertemporal distortions in the agent's choices. The most famous of which is what have you done for me lately effect, whereby agents overinvest relative to the what might be considered to be efficient allocation, overinvest later in the term and underinvest earlier in the term. Of course, to be able to say something about it, you want to think about politicians making choices in sequence, so you want to model a sequential policy choice. There are some models that we know about that I mentioned here, Serafidis and Muto and Shepsley, which do this, but they make explicit assumption of recency bias, and one of the things that we want to do is to show that we can generate this effect without abrogating our standard rationality assumptions. So we're going to have a model of moral hazard with sequential policy making, in which agents' choices are going to be preceded by communications from the principal, and I will make clear why we do this and exactly what form they take in a moment. And the principal is going to have retention authority at fixed moments of accountability. So the first thing I want to mention about this is that the retention authority, as opposed to a broader menu of tools that, say, contract theorists might use to analyze behavior, the principles typically conforms to our expectations for what happens in political settings generally. So this is I guess, a tidy way of modeling it. But the fixed retention authority at fixed moments, retention authority at fixed moments of accountability in particular, corresponds to what we see in a large number of senior government bureaucratic appointments. I listed here the alphabet soup of U.S. agencies: IRS. Everybody knows what that is. FERC is the Federal Energy Regulatory Commission, FAA, National Transportation Safety Board, then the commissions that everybody loves, like SEC, FTC, FCC. There are examples at the EU level. This is the European Food Safety Administration. In France, we have Competition Authority, PCA, PSA. I don't remember what it stands for, but I know it regulates banks. HHA regulates provision of healthcare. So these are examples of agencies where the governments, right, typically the president, in the US and France, this would be the president, are appointing politicians for fixed terms of office, right, and politicians are obviously going to be making multiple choices while in office, and then there are moments of accountability. So I want you to keep those in the back of your head. So here are main results. There are two. One is what we describe as a political time inconsistency problem for the principles, and it will be in the form of the principle's inability to effectively commit to a retention rule that would guarantee to the principle's higher level of utility. And we're going to see what the commitment problem comes about, how the commitment problem comes about. And the second result is going to be a novel argument for the value of eliminating transparency in political settings. Now, there's an extensive literature on transparency and why transparency might not be a good thing that grew out of these three papers: Prendergast, Kane, Drone, Karen, and Schatz, and Maskin and Troll, and it continues into the present. And the way those arguments typically work is in the adverse selection environment, in which the agents have an incentive to pool through the choices they're making, right? They have an incentive to pool with something that is described as a congruent type, right? Which is the type that the voter would like, or the principal would like to retain. So the pandering argument turns on the agent's investment into reputation. In our environment, you're going to see an argument against transparency, which will come from the fact that elimination of transparency makes it possible for the principals to make a commitment to deferring to the agent when the production technology is sufficiently uncertain, and that's what the principal would want to do. In the presence of transparency, he won't be able to do this, and so this is eliminating transparency is going to buy him the way out of the time inconsistency problem. We'll talk about the model. The model will have two policy stages. Each policy stage will start with a message, communication from the principal to the agent, followed by agent's choice. And after the second policy stage, there is a retention stage in which the principal chooses whether to retain or fire the agent. And we're going to give the agent total amount of resources A bar, and we'll look at several models, several portions of this model, but we'll start with a model where each of the two investments is capped. So the first investment is up to A1 bar, and the second investment is up to A2 bar. And the probability of successful outcome, and again, the principal is going to observe the outcome in this model. The outcome is going to be success or failure. The probability of successful outcome is going to be P, which is going to be increasing in A1, A2. It's going to be concave and satisfying another. So here the preference is the agent is going to care about retention and resources not spent on policy. He's going to get B if he retained. That's the benefit, fixed benefit of holding office, and the residual of what he is not spending. I think of this as a graft payoff. And if not retained, right, he gets to keep the graft payoff, and of course doesn't get to benefit of holding office, and the principal is just going to care about success. So the solution concept is an important part of the story here. In pure moral hazard games, there are lots of sub-imperfect Nash equilibria, and the way the equilibria are typically selected in political science.
This is after 2 periods is done?
After periods were done. So
the only reason why the principal retain
is going to be moral hazard. He will want to motivate the choices up front. So at the point, right, he's not actually going to be indifferent, as you will see.
Okay.
Right, we're going to generate a preference for the principal to behave in one way as opposed to another. So the standard move, right, for the selection argument is to say, let's focus on the equilibrium that maximizes the principal's welfare, right? And the intuition that is typically given is that you can think about the principal as making an announcement at the beginning of the game, right, of a retention rule, and at the point of actually casting the ballot, the principal is indifferent, right, and so he can implement the retention rule that he announced at the beginning. Right. Here we're going to model dynamic policymaking, so we want to make the communication explicit, and as you're going to see in a moment, this is going to create subtleties in what it is that the principal will want to say and when the principal wants to say it. And so the intuition for the solution concept we're going to adopt is that we want the equilibrium to be robust to small revision costs. Now, you can think about these costs as being partly psychological. Psychological costs of lying, where the principal is going to make one announcement and going to retain you if and only if, right, the policy or the choices we're making are at a certain level, and then fail to follow through. Or you can think of them as reputational costs. But the idea is we want to choose the equilibria that are going to be robust to the existence of these small costs of revision. And so formally, you can think about the equilibrium, our equilibrium, as the limit of a sequence of equilibria in a sequence of nearby games with ever smaller costs of altering declared retention rule between stages. And by the way, this is you can think of this as an extension of the standard selection criterion, because in games without sequential policymaking, it's going to select the maximal welfare. So what happens under this criterion? So in the retention stage, right, the principal is just going to apply the rule that was declared in the final policymaking stage. And that's easy. In the second policymaking stage, the agent is going to choose the second action, right, that is going to be best responding to the declared retention rule by the principal, M2, right, given the history A1. Now the principal is going to declare, I guess to declare M2, he's going to declare the retention rule that when best responded to by the agent is going to maximize A2, right? And that means that he will want to revise his initial announcement for low enough revision costs if there is sufficient amount of upside. Right? In the first policymaking stage, the agent is going to be anticipating that the principal will have the incentive to revise. And so the agent is going to be selecting A1 that is going to be best responding to the anticipated declaration M2. Right? And of course, the principal anticipating this will be forward-looking, and so he will declare retention rule M1 that best responded to is going to be maximizing A1, again, subject to the principal not wanting to revise the retention rule once the opportunity to make the second announcement comes about. In the second stage, the principal is going to declare a rule to extract as much of the second choice as possible, right, given the history A1. He can induce A2 prime following A1, if the expected value of reelection, right, expected fixed benefit of being reelected, plus the graph payoff, is going to give to the agent at least as much as what he gets by taking everything and foregoing the prospect of reelection. In particular, in equilibrium, he's going to be able to induce A2 that's going to be the minimum of either A2 bar, where the agent is maxing out in the second location, or A2 hat of A1, right, which is going to be this at equality, right, exactly at equality. Now, notice that he can induce A2 equal to A2 bar at histories with A1 less or equal to this value, right?